Okay, students, today we will start a new chapter. Before starting a new chapter, we will talk about matter. Okay, in the ninth grade, we had already discussed, okay, in the first chapter of your science, ki matter kya hai? What is the matter? So, I will not, okay, means a deeply uh, talk about the matter. Just basic kya tha? Matter is made up of a smallest particle. These particles are atoms. यही आपने किया था. ओके, तो नाउ वेयर द मैटर, ओके, वन क्वेश्चन इज रेज कि व्हाट इज द एटम. एटम क्या है? ओके, मैटर के अंडर आपने सॉलिड, लिक्विड एंड गैसी स्टेट वी हैड ऑलरेडी डिस्कस्ड इन 11th केमिस्ट्री. ओके, वी हैड ऑलरेडी डिस्कस अबाउट these things. Okay, because this one is the base of the chemistry. Okay, from the matter we will start the chemistry subject. Okay, so now in this class we will talk about the atom. Okay, it's a your physics chapter. According to the atom, okay, first thing मैं before बात करूंगा ninth grade. Okay, not a before ninth. Okay, from the ninth grade आपने chapter atoms and molecules start किया था after when you learned about the matter. Okay, after that you will continue. Okay, you had already continued the chapter is atom and molecules structure of atom. ओके, तो देन वन बाय वन, ओके, इसमें अब डीपली स्टडी होगी कि एटम्स के बारे में. उसमें आपने मॉडल्स किए थे, इसमें भी मॉडल्स करोगे, बट मेनी थिंग्स आर न्यू फॉर यू. ओके, इन फिजिक्स. ओके, कि व्हाट इज द एटम. एटम के बारे में बात की जाए तो एटम अकॉर्डिंग टू द डाल्टन, यू नो डाल्टन इज द फर्स्ट पर्सन, ओके, फर्स्ट साइंटिस्ट हु introduce the practically what is the atom. Okay, from the law of conservation of mass and law of constant proportion. Okay, they introduce the some key points. They introduce the theory postulates of atom ki atom kya hai. So in a simple and in a single line we can say atom is the smallest particle which is indivisible according to the डेल्टन. डेल्टन ने बोला था कि एक आप किसी मटेरियल को ओके कन्वर्ट कर रहे हैं स्मॉलेस्ट पार्टिकल में, एक स्टेज ऐसी आएगी वहां पे वो पार्टिकल आगे फर्दर डिवाइड नहीं होगा. वो फर्दर पार्टिकल जो डिवाइड नहीं हो रहा वो आपका क्या है? एटम. ओके, बट टिल दैट डेल्टन थ्योरी, व्हेन द थॉमसन, गोल्डस्टेन एंड बोहर, रदरफोर्ड are come in a science field, so they introduce atom is the divisible. So if the atom is divisible, so what is the structure of atom? So they introduce the models of a atom. Okay, this one is the introductory part of a atom. So then first J.J. Thomson who introduced the first structure, okay, model of a atom, and second one Rutherford, and third one is the Bohr. Okay, these are the three scientists who introduced the structural model of a atom. Okay, so in this chapter firstly we will talk about the J.J. Thomson model, Rutherford model and Bohr model. From that, okay, concept we will, okay, continue deeply study of this, okay, atom. So first topic after the introduction we will talk about the J.J. Thomson model. But according to the CBSE, according to the 12th grade standard, okay, it is not in your syllabus, but we will start from J.J. Thomson. Okay, so according to the J.J. Thomson we will talk generally कि J.J. Thomson ने कैसा मॉडल दिया था. Okay, तो it introduced the atomic structure model, okay, like a watermelon. वो कहता कि जो एटम का स्ट्रक्चर है लाइक अ वाटरमेलन है. वाटरमेलन में क्या होता है? रेड पोर्शन एंड ब्लैक सीड्स आर एम्बेडेड. तो दे सॉरी ही से द रेड पोर्शन ऑफ अ वाटरमेलन इज द पॉजिटिव स्फीयर एंड ओके सीड्स, ब्लैक सीड्स like electrons who are embedded in the positive sphere. आई रिपीट, ओके, वाटरमेलन में क्या है, वाइट सॉरी रेड पोर्शन इज हेयर, ओके, एंड ब्लैक सीड्स आर हेयर. अकॉर्डिंग टू जे थॉमसन, दिस रेड पोर्शन act like a positive sphere and electrons are embedded in it. Okay, electrons like a seeds. Okay, so this one is the model of a J.J. Thomson. Okay, and the next thing is the neutral. According to J.J. Thomson, in atom positive and negative particles are here. Positive means protons and negative electrons. Okay, protons and negatives are here. Okay, they he say कि in atomic model, in J.J. Thomson atomic model, the protons and electrons are a same magnitude, means the number of electrons equal to the number of protons. According to that, if the electrons and protons are same numbering, तो that's mean we can say कि वो तो न्यूट्रल हो जाएगा, वो तो न्यूट्रल हो जाएगा, पॉजिटिव नेगेटिव के साथ अट्रैक्ट, पॉजिटिव नेगेटिव, तो दैट्स मीन द एटम इज न्यूट्रल. दिस वन इज द ड्रॉबैक ऑफ द जे थॉमसन. ओके, अकॉर्डिंग टू हिज practically theory, is practically कि atom is the neutral. Okay, if the number of atom is equal to number of protons is equal to the number of electron. Okay, after that Rutherford introduced the model with the help of the gold foil. Okay, your syllabus, according to the syllabus, your chapter start from a Rutherford model. Okay, it's a very important topic, a Rutherford model of an atom. Okay, we take a gold foil, alpha particles are passing through them. Okay, so now we will talk about a Rutherford model. In a Rutherford model, firstly, this one is the diagram. Practically, okay, observations are here from the diagram. Who introduced the Rutherford? Firstly, we take a source. Source में से क्या होगा? Alpha particles are, okay. In a Rutherford model, okay, we observe the diagram of a Rutherford. Firstly, we take a source. Okay, not a we take a Rutherford, take a source. Okay, from the source, the alpha particles are emitted from the source, and there, okay, he used a lead bricks. Why the lead bricks is used? Because you know, when the alpha particles are emitted, so then it is move in all direction. Okay, it move in all direction for the particular direction. Okay, particular direction में लाने के लिए we use a lead brick. Okay, he use a lead brick. So then after the passing the lead bricks, the alpha particles are in a particular direction. Okay, so you can check it is in a straight direction. Okay, at the, okay, path he used a gold foil. उसने जहाँ पे एक gold foil use की थी. Okay, when the alpha particles are passing through the gold foil, so then from that, okay, where he used a screen, it is a detector. Detector used to counting the how many alpha particles are spot on a screen after passing the gold foil. So then he observed some points. Okay, these points are the postulates of a Rutherford model. So first one, first he observed कि alpha particles like a 1000 alpha particles. Okay, like 1000 alpha particles passing through the gold foil. Okay, he observed from 1000 alpha particles 999, or we can say 998 alpha particles passing through the gold foil. Okay, so now one or two alpha particles where he go, then, okay, from this, okay, he introduced some many alpha particles are straight in path after passing the gold foil, and some few are making the angle, and one or two alpha particles rebound back. ओके, ये आप उसका प्रैक्टिकली ऑब्जर्वेशन थी। ओके, उसने क्या किया था, अल्फा पार्टिकल्स को पास किया गोल्ड फॉयल में से, गोल्ड फॉयल में से पास होने के बाद ही checked, he observed the many, almost all alpha particles are passing through the gold foil, but one or two alpha particles are rebound back from the gold foil. Okay, so from that, okay, concept, in a center he say great, or we can say strong nuclear power in the center of this gold foil, who do not allow the pass through them. Okay, who do not the alpha particles pass through them. Okay, he say कि one strong nuclear power is here, one strong power is here, this power is the न्यूक्लियस। ओके, इस रदरफोर्ड मॉडल से हमें इंट्रोड्यूस किया गया था कि एन एटम इलेक्ट्रॉन्स एंड प्रोटॉन्स आर हियर, बट विद ओके न्यूक्लियस आल्सो हियर। ओके, so then these are the okay for the theory key points, which source we use, radioactive source था bismuth 21483। okay, this source okay used to the Rutherford for the experiment, and second one emission of alpha particles energy। ओके, जो अल्फा पार्टिकल्स की emitted एनर्जी थी, दिस वन अप्रोक्सीमेटली 5.6 मेगा इलेक्ट्रा वोल्ट, एंड थिकनेस ऑफ गोल्ड फॉयल एज 2.1 into 10⁻⁷ meter, and this one last one is the scattering. After okay scattering, you can check the one or two alpha particles rebound back. Okay, if you write these points in a theory, so okay your good impact on a examiner। ओके, जो मैंने बोला है these things तो आपने लिखनी है कि one okay source is here, okay from the source alpha particles are emitted, okay then he use a lead bricks for in a particular direction, after the okay that at a path he used a gold foil. Gold foil, why the gold foil is used? Because it is a ductile material। okay, you understand what is the foil? okay, there one is the big piece of a gold when we hammered on it, so it convert into a thin sheet of a gold, so this one is the gold foil, means alpha part okay charges are concentrate in the one we can say center, so this one is the strong nucleus is here at a center of a atom. According to that, the model is here। okay, according to that, and the okay at the center the nucleus is present। okay, I repeat, according to the observation, according to the postulate of a Rutherford, he say okay most of the part of the atom is empty at a center। okay, at a center the nucleus is present in atomic model, and protons are in a nucleus, electrons are move around the nucleus, but not okay he do not share the direction or the electronic configuration ki how many electrons are move in which shell, which orbit, कि कहाँ पे वो करेंगे। okay, he introduce only a most of the part of a atom is empty, and in the center of the atom is nucleus, and electrons are move around the nucleus। एंड डिटेक्टर यहाँ पे मैंने लगाया स्क्रीनिंग के लिए, डिटेक्टर काउंट्स हाउ मेनी ब्राइट स्पॉट्स आर हियर फॉर द काउंटिंग द नंबर ऑफ अल्फा पार्टिकल्स। ओके, तो अकॉर्डिंग टू द स्कैटरिंग वी कैन शेयर एन थीटा graph। okay, so this one is the n theta graph। okay, at a y axis we take a number of particles, alpha particles, and in y axis x axis we take the scattering angle, okay which alpha, how many alpha particles where which angle at a scatter, like a 20 degree, 40 degree, 60 degree, up to so on. And this one is the number of alpha particles are here. So this concept is related to the Rutherford. But here also the drawback is here. Okay, drawback kya tha? He say when the alpha electrons are revolving around the nucleus, it release the energy. Okay, he say कि when the electrons are move around the nucleus, so then electrons release the energy. इसे प्रैक्टिकली देखिए, एनी सपोज ओके एनी एथलीट रन ओके अवे फ्रॉम द सेंटर या इन ग्राउंड, ही रिलीज द एनर्जी मॉर्निंग, उसकी एनर्जी कोई और होगी, ओके आफ्टर 1 आवर उसकी एनर्जी रिलीज होगी तो एनर्जी डाउन होती जाएगी, और वन टाइम ऐसा आएगा वो गिर जाएगा वहां पे. ओके, तो सेम प्रोसेस इज हियर. इफ द इलेक्ट्रॉन्स रिलीज द एनर्जी during the revolve around the nucleus, so then at one time he fall in a nucleus. तो जेकर वो न्यूक्लियस में फॉल होगा तो दैट्स मीन तो ऑल होल एटम इज द पॉजिटिव. जैसे ही इलेक्ट्रॉन प्रोटॉन में गिरेंगे तो दैट्स मीन फिर अगेन न्यूट्रल. दिस वन इज द ड्रॉबैक. एंड नेक्स्ट, ओके, बोहर इंट्रोड्यूस द मॉडल from this drawback, he in atom electrons do not release the energy.